All right, number 11. A flag is raised up a flagpole in a jerky motion, right? In a jerky motion, using a hand-over-hand method. So which one of these do you think would represent that? Graph A, right? It's going up in a jerky motion. So it's going up, and then 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 it's going up. So graph A would represent that. Does that make sense? That's all we're at. If we looked at number 10, a flag is raised up a flagpole quickly and then more slowly, right? So which one is that? This guy or this guy? C. Why C?
Because it's like going up and then C.
Yeah, it goes up quick and then it just kind of goes up at a slower motion, right? Does that make sense? So what's 12? A flag raised up the pole at a constant speed. Constant speed. Usually that means we put it on a motor, right? And the motor goes at the same speed all the way up. So the flag goes up constant. Does that make sense? So constant, it's always, when you hear the word constant, you should think of the word linear. When something is going at the same speed the whole time, it should always, or going up by the same amount or down by the same amount, right? That's how we get up with a linear function, okay? Or a straight line. Does that make sense? Okay? So that's 10 through 11. And then we're going to do the next page here. Okay, and the next page, number 13, says for 6 months, a puppy gained weight at a steady rate. Sketch a graph to illustrate the weight of the puppy during the time period. And tell whether the graph is continuous or what I like to call discontinuous. So what do you think it means to be discontinuous or continuous? All right? So a continuous graph is one where you put your finger down, right? And you can draw over it without pulling your finger up or your pencil or whatever. Okay? A discontinuous graph is one that you have to take your pencil up or your finger up to draw the graph. Does that make sense? So this would be a discrete. This would be a continuous. What's this one? Discontinuous. No. Continuous, right? But if I were to start this and then said open circle and went like this, now it would be called a discontinuous. Does that make sense? Okay? So, that's easy. So what about the graph of the puppy? Let's turn this onto this board. And the graph of the puppy, okay? The graph of the puppy says, for 6 months, a puppy gained weight at a steady rate. Okay? So, how much is a puppy at 6 pounds? At 6 months? What do you think? Just an average puppy.
15 pounds.
15 pounds. Sounds good to me. So we go 5, 10, 15. Right? Okay? And then they said, during a time period, we don't know what time period, right? Could be months, could be years, right? But it's going to be a steady rate. What is that going to look like? At 6 months, right? Months. I gotta learn how to spell. Months, right? We have a certain amount. And then, whatever this is, this could be 12 months, right? This could be 12 years. I don't know, 12 years and 6 months. Whatever it is. But it's going to continue going off, and it goes up by the same amount. So whatever it goes up, So it started here. It's going to go up by the same amount each time. What does that end up looking like? What's happening to that graph? If it goes up by the same amount, what do we call this? We just use the word continuous. Yes, it is continuous. The puppy is continually gaining weight, right? By the same amount, so it's continuous. Okay, very good. And I'm going to take you, that's not right. But I want to take you a step further than what they're asking. Is this non-linear or is this linear? Linear. Why is it linear? Good guess though.
I don't know what that means.
Good. Linear. Which you don't know what it means. Take the root word.
Line.
Oh.
Right? Linear is just a line.
Oh, so it's a line.
Straight line. Okay? If it were non-linear, what would non-linear mean?
Like,
Not a line.
Not a line.
so it would basically be like up and down.
Any kind of curve. Anything that's not like... Is this linear?
No.
No. Is this linear?
No.
No. Technically, this is not linear. However, the dots create what we call a linear correlation. Right? Now, if we drew a line through the dots, then it would be linear. Does that make sense? Okay? All right. Perfect. So now, we want to come back to 15. But I'm going to do both 15, 16, or 14, 15, and 16 all at the same time. Okay? It's really, so far, pretty understandable, right? Okay? All right, so with this one, they say, give a situation. This is the writing, right? We got to write a paper over that, the movie we watched last week, right? This is why, because on the tests, we're going to be writing, and you have to write. I mean, that's the way it works, okay? So just because it's math don't mean we don't write, okay? And so right here, it's saying this is the distance from home, right? And then this is time. So what is this person doing as they're leaving home? Are they going away from home or towards home? Away, okay. So let's say I'm walking to the store. All right, I get to the store. Then what am I doing right here? How far away am I when I'm at the store?
Far.
I mean, however far, right? It matters. It depends, right? It matters if I'm going to the muck market, right? Or if I'm heading up to, I don't know, Walmart or something. Both places, different distances from here, right? Okay, so if I'm going down to the muck, right? And I stay there, right? I'm staying there. I'm buying stuff. Maybe I found some girl I'm sitting talking to. I'm like, hey, what's up? Hey. I still talk. So, you know, just sometimes. So, maybe I found someone to talk to. I'm talking with them. Maybe I'm trying to, hey, can I get a free milkshake or something? You know, I'm trying to get something free, you know. I don't know. I'm just trying to get something. Can I get a pepperoni stick? You know. So, but I'm looking for things to buy, right? Because it's a store. It's the reason why I went to the store, right? I'm going to get some pepperoni, some pop, some candy, whatever I'm getting, right? But that takes time, right? And I didn't really go any more distance from my house. I'm still at the muck, right? So, but then what do I do? I have to go home, right? Bring that food home. Wife's going to want some of that food, so I got to bring that home, right? Okay? So that's the thing right there. So we're going away from home. We're staying there for a while. And then we're going back home. Is that pretty cool? Pretty easy? Right? Now you can make up anywhere you want. You went to a friend's house. You stayed there. You did whatever. And then you came home. Right? The whole purpose is you did have to go from home and then you had to return to home, and wherever you went to, you stayed there for some time. Does that make sense? Okay? Now, how much time did you stay there? You stayed there for a lot more time than it took you to get home and leave home, right? So you should also understand that. If they ask you a question on the test, did you stay away from home like longer than it took you to leave and to get there and to get home from there? And in this case, yes. Because if I add this space and this space, it's going to be a lot more than that space, right? Does that make sense? The time we stayed there was a lot longer than going there and coming back. What about this one? What am I doing here? Something that costs versus time, right? So everything costs money, right? But over time, some things don't cost as much. And in this case, it still goes up. It just didn't go up as much. So it went up really a lot in the beginning. In this case, a lot of times this would be autographs. Like that right there, that's Conor McGregor's autograph, right? Okay, that cost me $250. Right? Now that would not show this, because Conor McGregor cost $250. Then it went up to $300, but then it went down when he lost, right?
That's a perfect line.
Right? So that's what's happening to the play. But with whatever this is, yeah.
We'll go up after this match.
Exactly. So then after the match, if he beats Alvarez, right?
Which he would.
Which he should, right? It should go back up.
All the way up. Bro, he beat him.
Right? Now watch. What's this saying? This is like a Russell Wilson signature. A Russell Wilson signature went way up the first year, right?
It still is up.
But it's still up, right? But it didn't go up as much, but it still kept going up, right? That's all this is saying. You got it? Okay? Right? You got that? Does that make sense? Right? Now, it doesn't have to be an autograph. You can do anything. A car value, right? A car value went up when you first bought it, but then it only went up a little bit. Typically, car values don't do that, right? What about this? Park visitors. Park. Someone went to the park, right, and they visited. There's this many visiting on this day, this many on this day, this many, and this many, and this many, and this many, and then this many, right, as the days went on. Right? So let's say it was a Point Defiance Zoo, right? And let's say they got the baby tigers in, right? They got the baby tigers in on the first day, man, everybody was going out. On the second day, not so many, right? And then on the third day, not so many, and fourth day, not so many, and the fifth day, and so it kept going down. Does that make sense? It'd be like the tigers at the zoo. Okay? Once everybody's seen the tigers, they don't go back to see them, right? Now everybody wants to see them on the first day. A movie, right? It's the same thing. A good movie comes out, what happens the first day? First weekend.
Everybody goes to see it.
Bam, right? And that's when it makes its most money, right? And then what happens the next weekend?
It goes lower.
Yeah, it makes a little less. And then what's the next weekend?
Lower.
A little less. And they take this data and they throw it in there and they start doing linear correlation with it. They want to figure out how long they leave the movie in before they pull it to put it on DVD and all this. I mean, this is real deal. This is what they do. Okay?